Today's lecture we will discuss about the regression using ANN with nonlinear optimizations. So what is meant by regression? Because in machine learning there are two types: supervised and unsupervised learning. Okay, in supervised learning, further it is categorized as a regression and classification. So in regression, just what is meant by regression means we are predicting the future values. Let us state there are two features they have given. If x is 1 and y is 7, then predicted output, that is output I am taking some it's a 21, like this. Some there is a relation. Okay, if x is 2 and y is 5, it might be a 18. Okay, some x is 4 and y is 3, it is 12. So this already I have given. And the next time they were asking that if x is 5 and y is 9, then what is the output? This we have to predict with the help of the available data. This actual output is available and we have to predict first, then find the error, then we have to minimize the error. That is especially will be done in the regression methods. So regression, simply what is conclusion of the regression is that it's simply we are predicting the future values without any errors. Okay, that's the rate. Now here it is the there itself in the normal regression methods we use to find the slope and intercepting point. Then we will find the regression lines here. Okay, you'll find the regression line in those cases. But here in the artificial neural network, now we have to train the algorithm in such a way that it has to predict the what is the this value. So by that way, in each iteration, the weights are getting updated by using nonlinear optimization. Here itself, in the last lecture, we discussed about the nonlinear optimization. So here we are apply this ANN in regression. Okay. So come to that. The problem is that already I have derived. So here I have taken two neurons. Okay, two neurons and two hidden layers. That is one hidden layer which consisting of two neurons and one output. The following weights I have given: 0.15, 0.20, that is a W11 equal to 0.15, W21 equal to 0.20, W12 is 0.25 and W22 is 0.30. Like this, there are three biases also I have mentioned. Now we are going to predict the this output with this input. Okay, and target output also will be given, that is a 0.01. This we have to get by using these inputs: x1 equal to 0.05 and x2 equal to 0.10. Okay, so if I am taking over here from this neuron, then the hidden layer which consisting of two neurons. So here it is the z1, the summation which is coming from here x1 and x2, that I am taking z1 x1 w11 and plus x2 w21, that is means from here and from here plus b1. The summation, it is obtained after substituting the values. Okay, so 0.05 multiplied with 0.15, this everything is after substitution, 0.3775. Likewise, same z2 here I have taken. So that is x1 w12, that is w12, and x2 w22, that is plus b2. The value has obtained 0.3925. So after receiving, after summation of this Z1 and Z2, we have to go for the activation, that we have to take the decision. So from this summation, so I have implemented this activation function by using sigmoid. So sigmoid formula, all of you aware that 1 by 1 plus e to the power of minus x. So here minus Z1. So after substituting this Z1 value, I am getting 0.59327. At the same time, this one is I am taking as A2. So that is Z2. After substituting Z2, I am getting 0.5968. Okay. So then after this one, we obtained output of this neuron is the 0.59327 and output of this neuron is the 0.5968. So now this, what is the ultimate output is that, so it is simply, let us take this one as A1. So A1 multiplied with W01, that is 0.4, plus A2 multiplied with 0.45, that is W02, plus B3. Okay, so that is a Z3 I have taken. The Z3 is the summation obtained 1.106. So plus total, this is because the actual output, predicted output which is obtained at the final stage, I am calling it as a Y prediction. okay, which is obtained from the Z3. So y prediction equal to Z3, that is 1.106. Now output is obtained. Then what is the actual output we have to get? That is 0.01. But the predicted output, which is calculated from this random weights, initially we have taken the random weights, that is 1.106. Okay. Therefore, we need to find the loss. How much loss is there? Whether we have obtained the exact target output or not. So find loss is the, I am taking mean square error. So that is a half into y prediction minus y target whole square. So after substituting these values, y prediction is which we have obtained, and y target is a 0.01, then the loss is 0.599. This loss we have to make it to 0. Otherwise, the incorrect results will be getting in future predictions. So therefore, first we have to reduce this loss by changing the weights and bias, because inputs and output is depending on input we cannot change. The only possible way is the all the weights and all the biases we have to modify, we have to update it accordingly. Therefore we can get the small loss, or otherwise almost all negligible loss. Okay, if the negligible loss means that's the final output we are obtaining. Okay, so this one next, that is called as a back propagation algorithm. So we have to go from the back side to predict the, to update the weights and bias. So what is the formula? Loss function already we know, this is the loss function. So which one we have to obtain? We have to update WO1, WO2, that is at the output side. These are the, okay, these are WO1 and W2O2. First we have to update from output to the hidden layer, and from hidden layer to the input side, that is a another section, that is we have to update W11, W12, W21, W22, B1 and B2. Okay, these all things we have to update. So here first I am updating the dou L by dou W1 because loss. But if you observe carefully in the loss, that is dou L by dou W, there is no weight component over here. So if I am differentiating directly, it tends to 0. Okay, it will give you answer 0. It means there is no loss, but it is an incorrect answer because we have a loss of something 0.599. So therefore, we need to modify this one to some other extent, that is to derivative to get the proper results. So this I have modified like this dou L by, because here y target we cannot change, only y predict can be possible. So this can be, I can differentiate. So therefore dou L by dou y predict. Okay. Then from here y predict we already know, this y predict is the, this one y predict equal to Z3. Okay. So therefore if I need to update this here, so we have a WO1 in this equation. So therefore directly I am writing dou y predict by dou W01. Okay. Now if you cancel these y predicts, again your left hand side which is equal to the right hand side. So the formula is correct. Now dou L by dou y predict, if you are differentiating this one, you will get y predict minus y target. And if you are differentiating with dou prediction with dou W1 in this equation, you will get the A1. Okay. So here then what is the y prediction? 1.106, and y target we know, and A1 you have obtained over here 0.59327. After substituting this one, you are getting this one 0.65082. The same way dou L by dou W2, only which term will be changed? Here only WO2 will be changed. So if you are differentiating this one, this time A2 will come, right? A2, and if you are that is y predict minus y target multiplied with A2. So after substituting these values, again you will get the 0.65376. Now another term is WO1 we have done, WO2 we have done, and one more is B3 we have to modify. So again, what is the formula for updating the bias? Dou L by dou B1 equal to dou L by dou prediction, dou y prediction by dou B. Okay. So B is always here B3. Sorry, here I have not written B3. B3, it is a, please make it correction, it's a B3. So B3, if I am differentiating, then you will get 1 automatically. So then output is the 1.09591. Okay. Now this is a section for the output from the hidden layer to the output side. And next from hidden layer to the input side, if you check dou L by, because we have to modify, again we have to do this one W11, W12, W21, W22, B1 and B2. So this time it is not possible to update the equations from hidden layer to input side, because these all are connected in a pipeline to modify the output. So we have to start from the last to initial stages. Okay, that's why again we have to take the dou L by dou W1. Here dou loss function is here, dou L by dou W1. How we can go this one, dou L by dou W1? See here, we have a dou L by dou Y prediction already we done here, and this time we should not differentiate with W01, because we have to go up to the dou W11. So if you check in the dou Y prediction here, then there is a term A1. So dou Y prediction by dou A1, if I am differentiating, you will get W01. Then dou A1 by dou Z, because A already arriving. So A1, if I am differentiating with A1 with the Z, dou A1 by dou Z, I will get one equation, and then dou Z by dou W1. Like this back propagation from output side to step by step we are moving towards the input side. Here is our target. The up to here we have to make the differentiation. So it is dou L by dou Y prediction, dou Y prediction, dou A1 by dou Z1, dou Z1 by dou W11. So all you make it cancel, again right hand side which is equal to left hand side. So here dou L by dou Y prediction is the, already we know, dou Y prediction by dou A1 means already I told you that this one, if I am making differentiating with dou A1, you will get W01. Okay. Next one is dou A1 by dou Z1 means this is the sigmoid activation function. If you are making differentiating the sigmoid function, then you will get f of z, that is sigma of z1 multiplied with 1 minus sigma of z1. And finally dou z by dou W11 means, that is you will get the x1. So substitute this all the values, you will get 0.00529. This is for the W11. The same way W21, if I am differentiating, only final one change. Next one is W uh, 2, then it will change. This is become A2. A small modifications in the differentiation, and you will parallelly will get the 4 results. And WB dou B1, sorry, dou L by dou B1, the same way, only here it will be changed. Dou L by dou B2 means it will come A2, and here it will become Z2 and dou B2, like this. A small modifications. After making the small modifications, you will get the final results. So this all after obtaining, then you have to go for the new weights. Okay. W01, what is the formula for the gradient descent algorithm? It is W01 new equal to W01 old minus alpha into dou L by dou W01. So W01 old already we know, that is here W01 old is a 0.4. Okay. So W01 old and W01 new, that is new equal to W1 alpha is a learning parameter. Here I have taken 0.5. So you may take up to 0.9 and up to 1. This is the range of the learning parameters 0 to 1. So either depending on the your choice, you may take it from anywhere. Okay. And dou L by dou W1 is the 0.65 we obtained. So after substituting these always, W01 new is the 0.07459. Likewise B new is the B old minus alpha into dou L by dou B3. Like this, all the parameters, new weights of the bias and weights are getting updated. So these are the weights and bias. Okay. This for W11, W22, W12, W21, B1 and B2. B3 already we have obtained. Okay. This one is a B3. Okay. So this after getting all the values, again we have to check the whether we are getting the proper result or not. If the again after doing the same operations, if your y loss is getting reduces to the 0, then we are stopping over here. If it is not reduced, again we have to repeat the process, repeat the process up to loss become 0. So this is the way of back propagation to update the weights and bias in order to getting the future predictions. So by using multi-layer perceptron, that is a artificial neural network we have implemented, that is a regression problem. Okay. So, okay. So thank you. If you like the video, please click on the like button. Thank you.